Alright, so I'm going to be doing two of the problems that were assigned on your homework. Problem number 6 and then problem number 26. So you were assigned 7 problems and I'm doing 2 of them for you, so you really only have 5 problems to do on your own. So I'm going to start with problem number 6. You're given 2 linear equations in a system and they're asking you which of the solutions works for both. So remember, the solution, the ordered pair, has to work for both linear equations. Otherwise, it's not a solution. So it only works for one and not the other, then it's not a solution. So the only way to do this is to start plugging them in, and once you find one that works for both, that's the one that you want, because remember, if it works for both, that's the only one that'll work. It's a linear equation, so there's only one point of intersection between the two. So A says -2, 0. That's the x, that's the y. First one's x, second one y. So let's go ahead and plug them in into the first equation and see if it works. -2 plus 0 equals to -2. I just plugged them in. -2 equals to -2. Check. So it works for the left one. See, it works for the right one. It's got to work for both, or it's not a solution. Seven times -2 is -14. -4 times 0 is 0, or just -0, doesn't really matter. -14 is not equal to an 8. Now that does not work. So A is out. Let's go to B. B says 0, -2. That's x, that's y. Let's plug it in and see what works. So plugging in 0 for x, that's 0. Y, sorry, -2 for y, that's -2. So once again, seems like it's working for the left one, but it's got to work for the right one as well. So let's plug it in for the other one. X is 0, y is -2. Okay, 7 times 0 is 0, minus -4 times -2, negative times negative is a positive. 4 times 2 is an 8, and 8 equals to 8. Yep, and it's B. You don't have to go any further. B is your answer because it worked for both, and there's going to be only one solution that works for both. You're welcome to work out C and D. They should not work. Alright, good. So I'm going to move on and do problem number 26, which is the last problem that I assigned you. So I'm doing the first one and the last one. The 26 is a bit of a toughie, mostly because it has decimals, and I know you guys love decimals. Alright, so this set of problems, 12 through 26, they're giving you 2 linear equations in a system, and they're asking you first to graph them, see where they intersect, find that point of intersection, and then check your work by plugging in that point of intersection back into your equations to see if it checks out. So the first things first, we got to graph. And to do this, we need to get them both into the slope-intercept form, which is this, y equals mx plus b. So I need to make this equation look like this one, so I need to isolate y. No problem. I'm going to add 1.6x to both sides first to get rid of that negative 1.6x, because we're getting rid of everything but the y. That's gone. Okay, then we're going to divide everything by a negative 3.2. So negative 3.2 divided by negative 3.2, that's gone. Negative 24 divided by negative 3.2. Well, negative divided by a negative is going to yield us a positive number. Outcome is going to be positive. And 24 divided by 3.2 is 7.5. And then positive divided by negative, the outcome is negative. 1.6 divided by 3.2 is a half, or 1 over 2, x. So I know dividing with decimals, not the easiest thing. This is why I chose this problem to do. So slope is going to be whatever's next to the x. That's a negative 1/2. The intercept is whatever's alone by itself. That's 7.5. So that's for the first equation. Let's go ahead and solve the second one. So for this one, first things first, you gotta subtract 2.6x from both sides. So once you do that, you get this, because I took away 2.6x on the left side, it's gone, and then I subtracted also 2.6x on the right side, and here it is. Then I'm going to divide everything by 2.6 to get rid of the 2.6 next to the y. Disappears on the left side or simplifies to 1. 26 divided by 2.6, that's going to be a 10. And negative divided by a positive, that's going to yield us negative. And 2.6 divided by 2.6, that's going to yield us a 1x. So here the slope is negative 1, or negative 1 over 1, just to make it easier. And the intercept is 10. Next step is to graph these two and see where they intersect. So the first one, the intercept is at 7.5. So 1, 2, 3, 4, 5, 6, 7, 7.5. So it's right here. And the slope is negative 1 over 2. So down 1 over 2. Down 1 over 2. Down 1 over 2. And that should be enough. 2 points or 3 points are usually enough to give us an accurate graph. So that's the first. If we label this A and B, that's equation A. B is, the intercept is at 10, so this was 7, 8, 9, 10, so all the way at the top of our graph. And the slope is negative 1 or negative 1 over 1, so down 1 over 1, down 1 over 1. So down 1 over 1, down 1 over 1, down 1 over 1. Let's graph this and see where they meet. So it seems like they're intersecting at this point right over here. And it takes some very precise graphing to get an accurate intersection point, so do be careful when you do this on your own paper. Rulers are advised. So this point is at x 1, 2, 3, 4, 5. So x at 5 and y at 1, 2, 3, 4, 5. Y at 5. So the intersection point is 5, 5. Excellent. So we're almost finished. The only thing left is to plug it in into both equations and see if it works. So the first equation was 1.6x minus 3.2y equals to negative 24. Plug in the x, which is 5, plug in the y, which is 5, and see if it is going to work. So 1.6 multiplied by 5 is 8. And then positive times a negative, that's going to give us a negative number. And 3.2 multiplied by 5, that's 16. So that's minus 16 equals to a negative 24. So when you go ahead and do your calculation, oh, it's a negative 1.6, haha. So it's a negative 8. Sorry, see how easy it is to miss things. So negative 8 minus 16, that's a negative 24, equals to negative 24. Checks out. Now let's try it with the other one, because it has to work for both or it's bust. It's both or nothing. Plug it in for the x. 5, plug it in for the y. Again, it's a 5. So 2.6 times 5, that gives us 13. Plus 2.6 times 5 gives us 13, equals to 26. 26 equals to 26. Check, it works out. So this is a valid solution. So 5, 5 is the valid solution for this particular system of linear equations. Thank you.